Hello and welcome to this webcast, Applications for 28 AWG Twisted Pair Cabling Systems. The webcast is being delivered by Thomas Baum, Senior Product Manager with Panduit. Panduit also is sponsoring this seminar. We thank them for making the event possible and for providing its technical content. And we thank you, the members of our audience, for joining us today. During the seminar, Thomas Baum will examine what 28 AWG Twisted Pair Cabling is, how it differs from the twisted pair cabling that you may have used up to this point, and advantages like space savings that can be gained by using 28 AWG cabling. He also will detail the trade-offs of using this smaller gauged cabling, 28 AWG. A little bit of housekeeping. At the bottom of your screen, you should see a red icon. You can use that to submit questions throughout the seminar. We'll have some time for Q&A with Thomas at the end of the seminar. For those who plan to obtain an attendance certificate for today's seminar, I'll walk you through that process just before we begin our Q&A session. If you have technical difficulties during this broadcast, please click the gold icon at the bottom of your screen, which is a help icon. Clicking that will open a window that answers some common technical questions. If the information there does not provide you the answers that you need, you can type your question into the Q&A window using that red button. A member of our webcast support team will work with you to correct your problem. So without any further housekeeping, it gives me great pleasure to introduce today's speaker, Thomas Baum. Thomas, whenever you're ready.
Thank you, Patrick, and hello, everyone. Today we're going to cover 28-gauge twisted pair cabling systems and their application for today's telecom rooms and data centers. And this is an exciting topic because these new 28-gauge cabling systems can be used immediately to help with current TR and data center challenges. Now, what exactly is 28-gauge cabling? Quite simply, it's smaller size cabling due to the smaller gauge of wire used in the cable. For example, most current patch cords use 24-gauge wire, and for a Category 6 patch cord, that looks like the red cord below. But customers now have the choice to use 28-gauge cabling in many cases, and for a patch cord, that looks like the blue cord below, which as you can see is much smaller in size. Our goal today is to outline what those size advantages mean to telecom room and data center applications, and also provide tools to help you understand if 28-gauge cabling is a good fit for your situation. So why is there so much excitement about 28-gauge cabling systems for today's TR and data center challenges? Well, whether we're talking about TRs or data centers, we're all being asked to do more with less there. And as we see in the picture, which I'm sure many of you can relate to, common challenges are things like downsized and small or crowded TRs, congested pathways, space for new equipment that's coming, or using high-density panels as a way to try to increase the density but having difficulties there. You also need it for Category 6 and 6A systems, which are currently being installed. And you're probably looking for both greenfield or new installation, or brownfield, retrofit, or revision applications. So a key point here, and the reason that we're talking about telecom rooms and data centers for this cabling, is that the space within those two areas is prime real estate due to its function and the cabling equipment combined there. Yet as we can see in the picture, the copper patch cabling often drives how well we can meet the space challenges there. For example, we can see in the TR rack shown that while there is available rack space in the upper left for new equipment, there's little or no room to effectively add the patch cabling that would be needed. And this is a very common challenge. Therefore, as we try to solve these issues in the TR and data center, we will be looking specifically at the role 28-gauge patch cords can have in addressing the space challenges. And just so you know, 28-gauge cabling can also be used in other portions of the channel with many of the same benefits, but since our focus is within the TR and data center, we'll focus on patch cabling today. So common patch cabling challenges seen in the telecom room and data center are these shown. Whether it's crowding or congestion that makes moves, adds, and changes more time-consuming, And looking at the pictures going from the switch to the panel, that could be patching bulk at the switch, entering or within the pathways, or at the patch panels, trying, especially when using high-density panels, having challenges with normal cabling. Or in the bottom right picture, the use of space-consuming layouts that do make it easier to work with the patch cabling bulk, but at the expense of added equipment cost, being horizontal managers, and low rack utilization. All of these drive up network costs, whether higher operating expense due to added time for moves, adds, and changes, or higher capital expense from equipment costs or the cost of low rack utilization. The goal then is how to address these cabling challenges in the telecom room and data center to help lower costs. Which brings us back to 28-gauge cabling and why it's just recently begun to be used within telecom rooms and data centers. Historically, a big influence has been the TIA 568 standard, first released 24 years ago, in '91, which established the 100-meter maximum length for a copper cable channel and incorporated common cable sizes at the time, with 24-gauge cabling being very typical as a carryover from the telecommunications twisted pair cabling. But as we've seen, there are new challenges in the data centers and TRs over time, driven by new network capabilities. And those have caused the industry to consider new ways to best solve the critical space issues within that prime real estate. And that is behind the excitement about 28-gauge cabling in the telecom room and data center. Not only is it significantly smaller than the typical 24-gauge cabling, like we see in the picture with 24-gauge cabling in red on the left and 28-gauge in blue on the right, but it can actually be used today in most common telecom room and data center scenarios to help solve the space challenges with increased pathway capacities, higher density layouts, easier cable management, and ultimately lower costs being the result. Stay with me over the coming slides and we'll dig deeper into how 28-gauge cabling does this. But a simple way to think about why 28-gauge cabling makes sense is the statement, giving up 7% to get over 100% back. Now, most people would do that, and they are doing it, and by the end of this presentation, you'll know exactly what we mean by this statement. Let's take a closer look now at the exact size advantage of 28-gauge cabling by comparing it to typical 24-gauge cabling. Here are the diameters and true-to-scale images of available 24-gauge patch cords in category 5E, 6, and 6A performance levels. And just a quick note that all of the dimensions that I'll be referencing in the presentation are from available Panduit product, not just because we have all these products, but because I can't speak to specific dimensions of other suppliers' products. So just to keep everything fair, we'll be discussing dimensions with Panduit product. Now here are the true-to-scale sizes of available 28-gauge patch cords in comparison, where you can immediately see the advantage in reduced size and reduced patching bulk, with the 28-gauge cords actually taking less than 50% of the space of traditional cords. You can imagine what that can do for your pathway capacities. Next, we'll take a look at what the size advantage means within telecom room and data center racks and pathways. For example, here is a typical vertical manager finger opening of 1 inch with a true-to-scale bundle of 24-gauge patch cords based on the dimensions that we just saw. As you can see, with 24-gauge cords, a 24-cable bundle of those cords is already interfering with the finger opening, meaning it will be hard to work with. In comparison, here is the true-to-scale bundle of 24 of the 28-gauge cords, again, based on the dimensions that we just looked at, which have a diameter less than the opening size as a bundle, and therefore fit easily and can easily be worked with. Another common pathway area to see the 28 gauge advantage is the vertical manager and its cabling capacity. In this example, we'll look at a very common 4-inch manager size, and we'll look at it fill to a 50% fill ratio. So we'll be looking at the gray area shaded on the screen. We use 50% fill because that level is essentially considered full for working capacity. And note that we're looking through a section of the manager with the door closed. So as we look at this comparison, for the 24 gauge cabling on the left, which is in red, we can see the capacity would be 213 Category 6 patch cords. Where on the right, for 28 gauge cabling, which is in blue, using the same fill ratio, the capacity would be 523 cables, an increase of 146%, or in this case, over 300 more cords. Now imagine what more than doubling the capacity of your existing manager could mean. In the case of many of the 4-inch managers that I'm sure many of us have seen, that would mean actually being able to fit the cabling in the manager and close the doors. So now we're beginning to see how 28 gauge cabling increases capacity limitations in existing applications. And I also want to point out that this 146% increase in capacity in that prime real estate where you need it most, this is the over 100% reference from our earlier statement. Now let's take a look at the space between cables when Cat6 patch cords are plugged into a typical switch or patch panel. For the 24 gauge cords on the left in red, the open space between the cables, as you can see, is just over 300 thousandths of an inch. Where for the 28 gauge cables on the right in blue, there is 400 thousandths of open space between the cords. Now this may not sound like much, but it's actually 27% more open space, which actually means a number of benefits. First of all, that means better port number visibility, especially when using high-density panels, as you can see in the picture. It also means easier cord management, since there is space for fingers and plug access, and for routing cords. It means better airflow and equipment cooling, which is especially important with large chassis switches, whether in telecom rooms or data centers. And finally, it means new configurations are now feasible, whether using fewer or no horizontal managers due to the ease of cable management, the effective use of high-density panels since the cabling bulk is reduced, or even new layouts like direct switch patching, as we show in the picture on the right, all of which are not as practical when using typical 24 gauge cabling. Now let's take a step back and put it all together, looking at a typical TR rack example to see what benefits 28 gauge patch cords could provide for an overall layout when you're faced with a need to change or expand. For example, maybe you've acquired some space and you're moving into that space. Maybe you're moving a group of people within the existing owned space and the number of people is changing significantly. Or you're asked to install some new equipment in a data center. Here on this slide, we have a very common 2-rack telecom room configuration, which you could also see in a data center cabinet, with one rack being used for the horizontal cross-connect field, which would be on the left here, and the other primarily used as a network rack, housing the switch and power supplies. This looks familiar to many of you, I'm sure, and it's really a staple within large office telecom rooms around the country. So let's take a few minutes to understand the current layout with 24 gauge cabling. In the cross-connect rack on the left, we have 9 2RU 48-port flat patch panels for a total of 18 RU, and we have 10 2RU horizontal managers totaling 20 RU for a total of 38 RU in the cross-connect rack. Now, looking at the network rack, on the right, we have from the top 2 2RU horizontal managers, 1 2RU 48-port patch panel, 1 1RU fiber tray, a 20 RU 6513 switch, and 2 3RU power supplies at the bottom, totaling 33 RU in that rack. So that altogether, 71 RU is being used to provide connectivity for 480 ports, leaving us 19 RU of available rack space between the two racks. However, if we look closely, we see that over 1/3 of the RU consumed is just in horizontal managers, which we've seen are commonly used with 24-gauge patching to manage the cabling bulk. Also, we see that our 480 ports are requiring 20 RU of rack space. So overall, we would consider this a relatively low rack utilization layout, with the patch cabling being one of the main drivers for that. Now let's see how 28-gauge patch cabling can help increase the rack utilization and open up more available space in the same rack layout. As we step through this, I just want to point out that the total port count and active equipment are identical to the 24-gauge layout that we just looked at. So now on the cross-connect rack on the left, the 28-gauge patch cabling allows us to effectively use high-density panels. And by high-density panels, I mean those with 48 ports in 1 RU. And that cuts in half the RU needed for patch panels for the same number of ports. The total now is 9 RU compared to 18 RU previously, saving us 9 RU. Also note that we are using 28-gauge patch with the increased port visibility and easier wire management, so we're able to easily use angled patch panels, which eliminate the need for horizontal managers to feed cords to each panel from above and below. Now, we're also able to use a single 3 RU horizontal manager just for getting cords to the other side of the rack, compared to 20 RU of horizontal managers used in the cross-connect rack before, saving us 17 RU just in managers. Put together, that's a savings of 26 RU of rack space, and the 9 horizontal managers that won't be purchased, of course, are cost savings there. On the network rack, we save an additional 4 RU by using the high-density angled patch panel and a single horizontal manager, meaning a total gain between both racks of 30 RU. That RU savings can be used now for immediate expansion within the existing space or as a more compact footprint for future deployments. With that much added RU available, we now have 49 RU available. It actually gives us another exciting option. And in an option B scenario, that could be to consolidate the existing equipment, network and cross-connect, into one rack, where you would still have 5 RU of open rack space because we gained 1 RU from consolidating the horizontal managers, and essentially gaining a free rack for expansion space for new equipment or handling cutover transition to a new switch, both of which are very common. This also provides a compact solution for future cases where there may be space for only 1 rack. So in either of these options, we have created available rack space for expansion within the existing real estate footprint, thereby avoiding the significant cost associated with expanding the TR rack footprint or room size, which in many cases, as we know, is just not an option sometimes. The net result is that this allows you to either put more in the same footprint, which you might have often in an existing telecom room or data center, or shrink the size of the footprint with the same amount of equipment, such as you might have for a future design. Your choice of what to do with the space savings is really up to you. Looking at another common example, here we see a different challenge where 28-gauge patch cabling can help, and that is in the congestion of the cable managers, both vertical and horizontal, and the overall amount of patch cabling used. This, again, is a fairly typical 2-rack telecom room layout, in this case using 2 8RU chassis switches for redundancy, for a total of 768 ports and cords, which are all taken to the cross-connect rack on the left via the horizontal and vertical managers. This layout does already use angled patch panels at a density of 36 ports per RU effectively, which is not as dense as the 48 ports that we just spoke about. And you can see how dense the patching becomes even at this density with normal 24-gauge cabling. Now, due to the cabling layout driven by the bulk of the cable, several different lengths of cords are needed in this case, which increases the time to install the patch cabling and to manage it over time. As you can see, the physical layout of the cabling also drives a very large amount of total patch cabling, in this case over 1 mile of cords. Now, here is a layout, an alternative layout, for the same number of ports using 28-gauge patch cords, which takes significantly less space, reduces the bundle sizes, and allows the effective use of high-density 48-port and 1RU panels, and eliminates the need for any horizontal managers. I'll just point out that in this case, there are still 2 racks. They are closer together, using a 6-inch manager as opposed to a 12-inch vertical manager, as is in the foreground. And the switches in the alternative case are in the far right rack, and they are the same chassis switches as in the near right rack. So very significantly, this layout allows a much more compact side-to-side configuration, which obviously reduces the total cordage needed, actually reducing by more than 60% the total amount of cable needed. So obviously reducing that amount of cabling by that much is going to have material cost savings, and the simplified layout and the cord lengths all being the same are going to reduce operating costs due to less time to install and maintain the system. Now I just want to point out that this new layout, circled in the blue box, simply would not have been feasible using 24-gauge patch cabling. We can see in the foreground case with 24-gauge cabling, the bulk of the cabling going through the pathway from the switch. And just imagine trying to work with that in a direct side-by-side scenario. We can see it's crowding the finger managers, as we looked at earlier, and the manager pathways. So with that in consideration, you can see the total impact of 28-gauge cabling to reduce the cabling bulk in those areas. So with having looked at those 2 examples in a little more detail, with all these advantages for today's needs, you might be wondering just why not use 28-gauge patch cabling everywhere? Well, there are some guidelines for use that we'll cover next to help you identify suitable applications. One of the most common questions that we get on the use of 28-gauge cabling is whether it complies to TIA standards. And the short answer to that is no. The reason for that is that the size of 28-gauge cabling is beyond the range specified in TIA 568C2, which, as we can see, is from 22 to 26 gauge for patch cords. Now keep in mind that the last major revision to 568C2 was in 2009, and the interest in 28-gauge cabling has been much more recent than that. There's also the 100-meter channel length that we talked about earlier, which 28-gauge patch cabling does not support. So for those reasons, it does not comply to the standard. However, 28-gauge patch cabling, at least in Panduit's case that is, does comply to the performance of the standard, and that the cords do pass all of the TIA 568 performance criteria, such as near-end crosstalk and return loss, or patch cords or within a channel when used within the length guidelines that we'll discuss. Now, when you think about it, this is really not unlike several things that are done today in field networks, such as home run cabling using patch cords or using stranded cabling for horizontal cable, neither of which are included in the standard, but which are often done. Also, I just want to mention, in the case of Panduit 28 gauge patch cords, I can say that these cords do pass the patch cord component tests as part of our 100% factory testing that we do to all of our cords. For 28 gauge cords from other suppliers, you would need to check with them on their testing practices and performance. Now, I just mentioned length limitations, and this is another usage guideline to be aware of when using 28 gauge patch cabling. TIA 568C2 specifies a maximum 100 meter length channel for copper cabling, comprised of 90 meters of permanent link cabling, which is in the center. This is typically solid cable, and a total of 10 meters of patch cabling, here shown as 5 meters on each end. For simplicity's sake, I'm showing a 2-connector model with the same gauge of patch cords used on both ends. Obviously, the standard also includes specifications for a 4-connector model, but the length limits are not impacted by that, so we're going to stick with the 2-connector model. 24 gauge patch cabling supports this configuration to a maximum channel length of 100 meters. Now, looking at what happens when we use 28 gauge patch cabling, a derating factor must be used which reduces the maximum channel length achievable. Let's look at 2 common examples to see the effect. In the middle example, the first blue one, the goal here is to maintain our 90 meter permanent link or horizontal cabling, because most typically that's going to be in place and not easily changed for an existing application. In that case, we can have a total of 6 meters of 28 gauge patch cords in the channel that can be used for a total of 96 meters of channel length. In an alternate case, where maybe it's more important to have that same 10 meters of total patch be all of the 28 gauge patch cabling, then the maximum permanent link length would need to be adjusted to 83 meters for a maximum channel length of 93 meters. Now, this 96 and 93 meter lengths, which are 96% and 93% respectively of the 100 meter channel, that ties back to our giving up 7% to get more than 100 back statement. So those are the 2 pieces of that value proposition when using 28 gauge cabling. Regarding the derating that I mentioned a moment ago, the shorter length channel is due to the higher attenuation of the smaller wire gauge that's used in 28 gauge cabling, as compared to, for example, 24 gauge wiring. To calculate the maximum channel length, a derating formula is used, which is pretty straightforward, and that's in the blue box as shown. There are 2 parts to the formula, one for patch and the other for horizontal cabling. Both of them, what you do is you take the total length of that portion of the channel times the derating factor for that portion of the channel, and the product of those 2 terms, rather the sum of those 2 terms, must not exceed 102 meters. So looking at an example, and derating factors that are common are shown here below. 28 gauge being 28 gauge stranded, that is, which is commonly used for patching, derating factor of 1.9, 24 stranded being 1.2, and 23 or 24 solid gauge being a derating factor of 1. Now, the 2 bottom derating factors are specified in TIA 568C2, and for 28 gauge, the value shown is for Panduit cords. With 28 gauge cords from other suppliers, you would need to confirm that information with them. So looking at an example in the bottom of the page, when using 6 meters of 28 gauge patch, we would have a patch portion that is 6 meters times 1.9 D rating, of totaling 11.4 meters, plus the horizontal or permanent link portion, 90 times a D rating factor of 1, so that's 90 meters. So 90 plus 11.4 is 101.4, which, as we can see, meets our criteria for being under 102 meters. So this would be an allowable channel. The same math would apply for the 83-meter permanent link and 93-meter channel that we looked at a moment ago, as well as many other variations. As a manufacturer of many 28-gauge cabling solutions, Panduit has a detailed 28-gauge installation guideline, which goes into the D-rating formula in more detail and gives some additional tables about length calculations if you're interested. This length calculation that we just reviewed covers the most common patching configurations. For example, patch lengths up to 20 meters. For cases outside of that, there may be some other factors that need to be considered to determine maximum channel length, but those are not very common, and those details are covered in the installation guideline document I mentioned. Now, PoE, or Power over Ethernet, is getting more interest lately due to the new standards in development and the new applications supported by them. And 28-gauge patch cords can be expected to be used with PoE systems. As you can see in the table, the power levels for PoE are increasing from 15 watts with the original PoE up to 60 watts and even 100 watts for the PoE++ specification expected next year. But the good news is that 28-gauge patch cabling can support even the highest PoE power levels being considered. The only guideline to keep in mind is the number of cables that can be bundled together in order to stay within the recommended maximum 15-degree C temperature rise. Now, TSB 184A is a technical service bulletin from TIA that deals with the topic of PoE cabling and bundle sizes. And it references a maximum bundle size of 100 cables, which, practically speaking, a 96 cable bundle would most likely be the size that you'd be working with, since that's a multiple of 24 cables. And that's shown at the bottom left-hand side of the page. However, when using 28-gauge cabling, due to the smaller size of the cabling, more heat buildup can occur as the cables are closer together. So in order to stay within the recommended temperature rise, the cables must be grouped in smaller size bundles, such as 24 or 48 cables, like in the bottom right picture. By bundling them in smaller size bundles, it allows more airflow around the smaller groups of cables so that the temperature rise can be kept in check. Now, just to point out, in the chart above, for current PoE and PoE+, up to 48 28-gauge cables can be bundled together. And for the expected higher PoE++ power levels, up to 24 cables of 28-gauge cords can be bundled together across all three categories of performance. Also, just to point something out about what we mean when we talk about bundles. As you can see in the pictures at the bottom of the page, we're referring to groups of cables that are bound with a tie or a wrap of some kind so that there's no airspace between the cables. We're expressly not talking about cables that are just near each other in a pathway where there's airspace allowed to be in between them. So here again, these specific bundle size recommendations of 48 and 24 cables for PoE are as tested with Panduit 28-gauge patch cords, and for other suppliers, you would need to check with them. So, with these usage guidelines in mind and the advantages that we looked at, here is where we recommend that 28-gauge cabling solutions be used as compared to 24-gauge cabling. Looking on the left, whenever you're looking for relief from overcrowded pathways, such as in an existing application, or need a higher density layout, for example, working in new configurations or a desired new layout, and where a channel length slightly less than 100 meters is okay, 28-gauge cabling solutions are ideal. Looking on the right side, however, if you have examples, rather you have cases where the full 100-meter channel length is needed, or there's PoE use with bundles of more than 48 cables at a time, or where full compliance to the TIA standard is required, then those are cases where 24-gauge patch cabling should be considered. Let's take a moment and look at available 28-gauge products. Now, most of our focus in this discussion has been on patch cords. But when considering a supplier to work with, you also need to look at supporting 28-gauge components like jacks and plugs if you plan to do any field modification of cords. This would be things like cutting off a plug of a cord and terminating a jack onto it to make an equipment cord in the field, or maybe cutting down a patch cord to make it shorter and needing to put a new plug on it. The reason that you need to look at specific 28-gauge solutions for jacks and plugs also in that case is that the much smaller wire size of 28-gauge means that jacks and plugs designed to work for 24-gauge almost certainly are not going to work for 28-gauge cabling and cannot be used when terminating to the 28-gauge cable. Now, of course, a 28-gauge patch cord shipped as a patch cord as an end product can be plugged into any standard RJ45 jack, regardless of the cable terminated to that jack. In fact, as we've already seen in the examples and in the diagrams in this presentation, nearly all 28-gauge patch cords in use today are used in a mixed gauge channel environment, where the permanent link and maybe even the patch cabling on the other end is the typical 23 or 24 gauge cabling respectively. Now, it's a shameless pitch for Panduit products. For the commercial that you probably knew was coming at some point, we offer a full range of 28 gauge cords, jacks, and plugs needed for any typical field configuration. And we offer those across all three performance categories of 5E, 6, and 6A, which to my knowledge makes Panduit unique as having the broadest line of these 28 gauge products by one supplier in the industry. In addition to those core products at the top, we offer some unique time and space saving solutions in 28 gauge assemblies for category 6 applications, like our switch harnesses, which are pre-bundled and pre-labeled groups of patch cords in common configurations that could very often be used in configurations that we looked at a few moments ago, and the switch patching kit that we looked at earlier. Thanks for allowing that quick commercial. And again, if you're going to be doing field modification of patch cords, please keep those other components like specifically designed 28 gauge jacks and plugs in mind. So, in conclusion, on 28 gauge cabling, we feel, and much of the market seems to feel, that it is an exciting new area in copper patch cabling that can provide immediate help with current needs, like increasing pathway capacities, achieving higher density layouts, getting easier cable management, and ultimately reducing both initial and operating costs in the TR or data center. Just remember to keep those guidelines and channel lengths and PoE bundle sizes in mind, and happy cabling. Now, as a reward for your attendance today, in addition to the BIXI Continuing Education credit that you will receive, in the follow-up email you can request a free sample of Panduit's new Category 6A 28 gauge patch cord, as well as getting a copy of the 28 gauge detailed installation guideline that I mentioned. Thanks so much for attending, and everyone have a great day.
Thomas, thank you very much for that information. This is Patrick McLaughlin once again, and I am going to allow Thomas to take a sip of water while we prepare for Q&A. While he's taking that sip of water and we're gearing up these questions, I will provide a little more detail on the attendance certificate that Thomas just mentioned in his closing. So before we begin Q&A, just want to let you know that your attendance certificate will be available through one of the icons that you see at the bottom of your screen. It's the one, the icon, the color of which I've never accurately described. I call it purple. Some people call it rose. If you see anything that's a button that's anywhere in that color family, please know that that is the button or the icon behind which you'll be able to access your certificate. Your achieving that attendance certificate today is based on the amount of time that you spend with us in this seminar. So when you have spent that sufficient amount of time, the certificate will be available for you to click and download from that particular icon. So I'll move now to this final slide, which contains an email address where you can reach out to us if you do not get access to that certificate today. We do have the ability to monitor and track your attendance today, so provided that you did spend that sufficient amount of time, if you did not receive your certificate, we will send one your way. If you email us at the address that you see here, which is webcastmaterial@penwell.com. So more housekeeping out of the way. Thomas, have you taken that drink of water? Because we've got more than a couple of questions here, and I think we'll be able to go pretty close to or right up to the top of the hour with this Q&A, perhaps. If you're ready for it, I know that several questions are ready to go.
Excellent. Yep, we're ready. Bring them on.
Thank you. Thanks. One question. Are 28-gauge patch cords more vulnerable to microbends than the 24-gauge cords that are so common in the market? Okay.
First of all, thank you for the questions. Really appreciate the interest in sending on the questions during the presentation. To the question, they're not really more susceptible to microbending. They do when you look at the minimum bend radius for cabling. It's based on typically a 4x of the cable diameter. So naturally, with the cords being much smaller in diameter, they allow a much smaller bend radius than the corresponding 24-gauge patch cords. But that does not mean that they're susceptible to microbending.
Thank you very much for that. Next question. You addressed this question came in fairly early on in the presentation. You addressed some of what's asked here, but I think there's some information that could kind of serve as a follow-up. It begins, what are the heat concerns, which I know you addressed. What are the heat concerns? Also, insertion loss, channel derating for smaller diameter conductor, stranded or not. Again, I think you got into some of that. Current carrying capacity of stranded 28-gauge compared to 24-gauge solid conductor.
Okay. Several topics that we did cover in the presentation, and make use here, or attempt to make use of our ability to go back and look in the presentation. So I think maybe showing on the screen now is the slide about the POE bundle sizes. So with respect to the portion of the question about the heat rise, so the heat rise specifically has to do with the POE considerations, and typically that 15-degree C rise that we referred to, that is a part of a concern for the cabling moving from a high ambient temperature of, say, 45 degrees C and not getting above 60 C, which is a common jacket temperature rating of many cables. So that's where the 15 degree C T-rise reference comes from. And what we're doing here with the cabling by breaking it into smaller size bundles is, with the POE being applied to the cabling, we are staying within that 15 degree C T-rise. So, Patrick, there was a second portion of that question, I believe, just having to do with current carrying capacity, which really is covered with POE in the comment that all of the cords, at least in Panduit's, which I can speak specifically to, they are all capable of carrying even the elevated 60 and 100 watt PoE power levels. So no issues there. It's not an issue of the cabling being able to carry it. It's simply an issue of when you bundle cables, and again, when we say bundle, we're talking about tight bundles of cable that can't breathe next to each other. The cables individually can certainly carry the current. And then I think a last portion of that question, if I recall, had to do with the length and the derating factors. So let me see if I can make use again of this capability. And Patrick, we should be seeing the slide with the lengths on it. Is that?
That's right. Yes.
Is that true? Okay, good. So this is a section where we dealt with that topic. And essentially, we can see the comparison between systems using 24-gauge patch cabling, achieving the 100-meter channel, and systems using 28-gauge patch cabling, which, depending on what you're trying to do, for example, in the middle case, trying to maintain your 90-meter permanent length, that you could achieve a 96-meter channel, or you could achieve a 93-meter channel if it was important to you to have that 10 meters of spec-allowed patch cabling done on both ends as 28-gauge cabling. And as we reviewed, and it's covered in much more detail in the installation guideline that I mentioned, and I would highly encourage the person submitting this question, as well as everyone, to, in the follow-up email, take advantage of that, getting that 28-gauge installation document, because it covers this topic of the derating and tables in various configurations, because let's be honest, there's almost an infinite number of combinations that could be desired by someone out in the field, so it's really hard to make a blanket statement. But it basically comes back to this derating factor that we looked at here. And some of those derating factors are specified in the TIA 568C2 standard. Others, such as 28-gauge, really needs to be provided by the manufacturer. And I hope that addressed the different parts of that question. And do we have others?
Yes. Yeah, there are others. Thank you again, Thomas. One question, what you're describing sounds great, but do we lose any measurable conductivity, speed, etc. by using 28-gauge?
Thank you, Patrick. The short answer to that is absolutely not. And I just want to go back for a moment here to one of the slides where we spoke about this topic. The reason I can say that is back to this statement here, the lower half of the slide, where we talked about these products, at least in Panduit's case, they are completely performance compliant to the standard. You can take your Fluke handheld meter and you can test in the various portions of the channel, either as if you have the patch cord adapters, you're going to test the patch cord as a component, or if you want to test the entire channel with the patch cords, the 28-gauge patch cords as part of that channel, subject to the length limitations we looked at, and you test that channel or that patch cord as a component test, it will completely pass the necessary criteria in all aspects. Wire mapping, of course, near crosstalk and return loss. You will see no difference in the Fluke test report. And this really, and this is a great question, I appreciate whoever in the audience asked it. This is a great question because it is one of the key things that most people want to know when they look to use 28-gauge cabling systems. And when they find that it's completely performance compliant, subject to the length limits that we talked about, this is where people get really excited, because basically it is that equation or that statement that we talked about. They're willing to give up 4% or maybe 7% in the overall channel length to get this massive, over 100% increase in pathway capacities. Other things that we didn't even spend so much time on, increased flexibility of the cabling, just the overall ease of management of the cabling. So I hope that addresses that question, Patrick.
Yes, absolutely. Thank you. Another question asks if there is an ETL verification channel report available with the 28 gauge cords?
Yes, there is. Yes, in Panduit's case, we absolutely have that.
Terrific. Next question for you, Tom. If you need to take another drink of water, feel free. I'll take my time on this question.
No, go ahead.
Question asked. Thank you. Question asks, what happens if the standard Cat6a patch cords are utilized at the workstation? Cat6a cabling is used in the horizontal for 90 meters maximum, and then the smaller diameter, the 28 gauge Cat6a patch cords are used only in the telecommunications room.
Another great question, and for that, I want to go to this slide here for a moment. And Patrick, please let me know when that slide's all the way up. So
I'm seeing the slide, Thomas. I believe the audience is seeing it.
Great. So the question, if I understand it correctly, has to do with basically, as I show in these examples, both the patch cords on both ends are of the same gauge. The question, as I understand it, is what if one is a 24 gauge, such as at the workstation, and the other is at the 28 gauge? Well, then you actually have a situation, the same derating formula applies, but now because you have patch cords of different deratings, you've got to have two different patch terms. The good news is that if we look, for example, at the top channel of 100 meters and the middle channel of 96 meters, we could take the 5 meters, let's say that the left end of the page is the work area. And we're going to have 5 meters of 24 gauge patch cabling in the work area. Our 90 meter permanent link is the same. And then on the far end, or rather in the telecom room, we're going to apply 3 meters of the 28 gauge patch. Well, you could do that combination, and as you add up those simple numbers of 5, 90, and 3, you now can achieve a 98 meter channel. So the same math applies. You just have to remember that when you start mixing the gauges, that you do have to consider, basically, if you know that the other gauge is 24 gauge that you're working with, you're only looking at the incremental difference on one end. So the good news there is that now the channel length that you can achieve is even higher than what I've stated here. These are conservative estimates on the basis that you might use it in both places. But if you use it just in one, you actually can achieve a higher channel length.
Thank you, Thomas. Our next question I don't want to jump to a conclusion, but may benefit from a reference to this very slide that you have up, but certainly you be the judge of that one as I extend the question to you. It says that understood that in your presentation you showed a 2-connector model probably for the sake of simplicity, but question asks, will the insertion loss associated with added connectors reduce the maximum channel length further?
No. That's actually, again, another great question. Thank you all very much. The simple answer to that is no, in that whether using the standard RJ45 jacks that you would find terminated to 23 and 24 gauge cabling, or even if you happen to make an equipment cord out of a 28 gauge patch cord and use a 28 gauge jack, that allowance in the channel for up to 4 connectors in the channel of the insertion loss, that allowance is already dealt with in the 100 meter standard. Allowable configurations covered by the standard at 100 meters are 2, 3, or 4 connector configurations. So essentially the simple answer is no, because that allowance for insertion loss by the added connectors is already built into the standard. And I hope that is clear there.
Right. Thank you. I think it is. Next question asks is there a recommended shortest 28 gauge patch cord? In other words, don't use a 28 gauge patch cord any shorter than blank. Is there such a recommendation or requirement?
Well, for practical purposes, in the case, for example, with Cat6 patch cords, and a good visual on this is the. Let me go to the front of our deck here. Good visual on this is the patch cords that would be used in the bottom right picture in this direct switch patching case. The practical answer is about 6 inches, and that's the length at which you could actually go between two adjacent ports in a switch to an adjacent panel and have enough working room. And there's essentially no concern about the length of a cord that's short when it's used as part of a normal length channel beyond. And that's why Panduit is confident in offering those products basically without qualification because of the intended use of using it as part of a short interconnect up to a normal length channel.
Thank you, Thomas.
I mean, I suppose that in theory they could be shorter than that even, but then it begins to be, what do you do with it? If you don't have enough room to work with and space to unplug and access things, then just practically speaking. But that's Panduit's position.
Sounds like it's a matter of practicality as opposed to electrical performance, right? That kind of dictates the shortest length. Right.
Yes. And I can tell you that these very short cords are quite popular.
Next question asks if do you have available field terminable 28 gauge patch cord or patch cable? I guess might be the best term to use there that can be terminated in the field.
I see, and if I understand that one correctly, it would be like bulk patch cabling. And if that's indeed the question, from Panduit the answer would be no. That we offer for stranded cabling options, while we do offer a large range of solid cable offerings, across all categories for horizontal cabling, which is typically purchased or very often purchased in bulk. For patch cabling, we do not, but I do know that there are 28 gauge bulk patch. There is 28 gauge patch cabling in bulk available on the market. We don't supply it, but there are other suppliers that do. And for that, I would just reference the specially designed 28 gauge connectivity options that we offer as a way to actually terminate that in the field. Great question, though.
And thank you for that answer. Next question asks, EMI, electromagnetic interference, is it an issue or a concern with 28 gauge cords?
No, Patrick, in that one, no more so than it would be with any other gauge of cord. And actually, that's a good opportunity to point out that while we have focused in this presentation almost exclusively on unshielded twisted pair examples, all of the dimensions that I mentioned in examples were showing unshielded twisted pair. And that's because, of course, the prevalence of that in the U.S. market. In the case of the Cat6A 28 gauge cords, we actually do offer both a shielded and a unshielded UTP solution. So many times for EMI concerns, low frequency noise and such, customers will look to shielded solutions in those cases. And for those situations, we do have the 6A 28 gauge cable. But as a simple response, there's no more concerns that you would have otherwise for other types of common cabling.
Thomas, thank you very much for that answer. As I look at Thanks again. As I look at my clock, I realize we've reached the top of the hour. But I'm sorry, I cut you off twice now. You're saying great set of questions, I imagine, was your comment.
Yes. That's it, Patrick.
Thank you. And there are questions that came in that we are not going to have the time to answer right now. So Thomas, you can take that other drink of water now because I won't be asking you any more right now. But please know those who submitted questions that we have captured those questions, and it's possible that you may be hearing some responses to your questions as we move ahead offline. Would be outside the course of this seminar because we are just about to wrap up. Again, the slide that you see on your screen has an email address where you can reach us if you do not receive an attendance certificate today, cannot download a certificate today, and do need one from us. So on behalf of Cabling Installation and Maintenance, its parent Penwell Corporation, I offer a great thanks to Panduit and to Thomas Baum for today's presentation. Of course, we thank all of you for joining us and very much appreciate your attendance today. We certainly hope and trust that you've gained some valuable information today. And once again, thank you for joining us. Thank you all, and please have a good day.